Hey guys, and welcome to this new course. In this one, we are gonna learn how to create procedural jigsaw puzzles. So cool. Okay, so here is the main thing that we are gonna learn in this course. We are going to grab an image, any image that we want, and maybe later on, I'm also going to show you how to allow the player to select or to take a picture with his camera and use it as the base or the texture for the jigsaw. That's gonna be awesome. All right, so basically we will have an image that we are going to separate into multiple pieces like so. Let's just use 9 pieces actually. Perfect. And we are going to do so by using the tiling and offset of the material. Okay, that's going to be so cool. So each little piece here, let's say this one, will go from 0 to 0.3 actually, on the x-axis, and same thing on the y-axis. Right here, it's going to be from 0.3 to 0.66, and finally to 1. So this is for our offset, and the tiling will be the same for all of the pieces right here because it's a grid of 3 by 3. So we have the same amount of lines as we have columns. Okay. So I hope this is clear. It's going to be way clearer when we are going to work on this in Unity. So let's jump right there. Boom, here we go. So I've simply created a 3D URP template here, so you can do so. I'm sure that you know how to do it. And what I'm going to do right away is select Build Settings and switch my platform to Android. By the way, just forgot to tell you here, but of course we are going to add knobs and holes to the image right here. So it's not going to be squares. It will have like small assets like this. Well, not like this, but come on, something like that, and so on. Like a regular puzzle actually. And you will be able to change the shape of these assets. And it's going to be awesome. Like so. Did I forget one? Nope, we're good to go. Cool, let's now jump back to Unity. Okay, the platform has been switched. Awesome. So now I'm just going to rearrange my layout a little bit. Okay, let's select iPhone 12 Pro Max, something like that. It's a bit too huge, so let's keep it like this. Perfect. And let's jump right into it. So the first thing I'm going to do here is to create a grid of spheres. Why spheres? Because it's a simple shape. And then we are going to convert that to a grid of quads. So let's do that. Let's right click, create an empty game object. Let's reset its transform and call it grid parent, something like that. I'm going to remove the volume and maybe I can keep the directional light for now, but select the camera and change the background type to solid color. Let's try and grab something a bit happier. Yep, this one is good. So let's create a prefab for our grid parent. So let's right click, create a 3D object, sphere. Here we go. Let's reset its position. I'm also going to set the Y position of the camera to 0. Here we go. And let's start making our grid now. Okay. So I'm just going to create a new folder for the project, Jigsaw Puzzle Course. Let's select everything, drop it inside of here. Let's create a prefabs folder, like so. Grab the sphere and drop it here. You know what? We don't need the collider, so let's remove it. Awesome. I can also remove the sphere. I'm going to create a new scripts folder and create the grid, grid placer, grid container, grid generator. Yep. So grid generator. This is just to first show you the logic on how to create a grid, because this will come in handy when we'll want to create our puzzle here with the texture. So let's attach this script to the grid parent and open it. Okay, so we first need a reference to our sphere. So let's create a header, elements as usual, not elements1, but elements. Serialize field, private game object. Let's call it sphere prefab. Okay. Inside of the start method, I can simply call the generate grid. Okay, let's create that method, private void generate grid. Here we go. And let's start creating our grid. So for that, we will need to set up some settings first. So let's create a header for that. Settings, serialize field, private. We are gonna use a square grid for now. So let's write int grid size. This is the amount of lines and columns that we will have. So if the grid size is 3, like we've got right here, we should have 3 lines and 3 columns. Okay, so a 3x3 grid. Cool. Then we will need the grid scale, but for now, let's keep the scale at 1. Okay. We are going to start from the bottom right. So let's specify this position right here. It should be minus the grid size divided by 2 along the x-axis and minus the grid size divided by 2 again along the y-axis. Okay? So vector 3, let's call it start pos equals vector, where is the e? Oh, vector 2 dot left times our float grid size divided by 2 plus vector2 dot down times again float grid size divided by 2. Okay, here we go. So this is our start pos. What we can do is spawn a sphere at that position. So let's instantiate a sphere prefab at start pos quaternion dot identity for the rotation, and we can spawn it under this parent. Okay, so now let's go back to Unity. I'm gonna set a grid size of 3 and specify the sphere prefab here. So let's lock the inspector, select prefabs sphere. Here we go. Let's now hit play. And perfect. We've got our first sphere at, let's see. Oh, the inspector is locked. Minus 1.5, 1.5. So let's move the other one at 0 and the other one will be at 1.5. Perfect. So let's go on and spawn the other ones. I'm going to go back to the script, and for that, I'm going to use a loop. So for x from 0 to grid size, and for y from 0 to grid size. So this is a double loop to allow us to loop through each cell right here. So if x equals 0, we are going to loop y from 0 to grid size minus 1. So it will go from here, x equals 0, but y will go from 0, 1, and 2, because grid size equals 3. Then we are going to increment x, so x will be equals to 1. So this is going to be 1, 0, 1, 1, and 1, 2, and so on. Okay? So this double loop allows us to iterate through each cell of our grid. Perfect. So for each cell, we are going to calculate the position. So vector 3 spawn position will be equals to our start position plus vector 2, let's say dot right, plus vector 2 dot up. But not just like that. First off, let's use vector 3s actually. It's going to be better. But this is going to be vector 3 dot right times x, so the value of our line right here, and vector 3 dot up times y. So let's now spawn our sphere like so. Boom, just by moving this line. And just for you to know, you can hold Alt and press the arrow keys to move a line in Visual Studio. Let's use this spawn position. And we can make this a little bit simpler, but yeah, let's keep it as is for now. Yeah, let's not overcomplicate things. We can go back to Unity, hit play, and we've got our grid. But there is an issue here. Seems like the grid is not centered, is it? Because it starts at minus 1.5, it should be starting at minus 1. And then, yeah, the second one should be at 0. And the third one should be at 1 along the x-axis, of course. Okay, so what's wrong here? The sphere has a size of 1 here. So we need to move by minus the grid size divided by 2. Okay, so this is minus 1.5 plus half the size of the cell. Okay, So right now, the size of the cell or the sphere is 1, but we need to take that into consideration. So let's use it here. StartPos.x plus equals .5f, because our scale is 1 again, and startPos.y plus equals .5f. Later on, when we'll use the grid scale, we're going to use the grid scale right here and not hard-coded values. So let's now go back to Unity. Let's hit play. And we've got our grid centered. Awesome. Let's use 5 as the value. Okay. And just for faster iteration, what I'm going to do is select Editor in the project settings. And of course, you can select Edit Project Settings to display this window. And enable the play mode options. This will help us hit play and prevent recompiling every time. Okay, here we go. So a 5x5 is working. What about a 4x4? Yeah, 20x20. Perfect. So our grid logic is working. In the next one, let's add the grid scale parameter so that we can scale these spheres and thus the puzzle pieces. See you in the next one. Welcome back, guys. In this lesson, we are going to implement the grid scale that will allow us to scale our spheres and thus our grid. Okay, so let's add the grid scale parameter. So let's hit Ctrl D here. Let's turn this into a float on grid scale. Perfect. The first thing that we want to change here is our start position, of course, because now we need to take that into consideration. So here is what we're going to write. Start position equals vector2.left times float grid size divided by 2, of course, but we need to multiply this by the grid scale. So grid scale times grid size divided by 2. And same thing here, grid scale times grid size divided by 2. Okay, grid scale, of course. And because the grid scale is a float, we can do this, okay? Remove this parenthesis and remove the cast here. No need to use the cast because it already becomes a float, okay? So let's remove this parenthesis, drop it here, and remove the cast. Here we go. Right here, the start position.x should be the grid scale divided by 2 and not .5 because previously we've used this hard-coded value because the scale of the sphere was 1. So right here, we're going to set grid scale divided by 2 and same thing for this one. Perfect. Finally, we also need to take into consideration the grid scale in here when we spawn the sphere. So it should be x times grid scale. And same thing here. Grid scale. But we can refactor this. So let's remove it from here. Okay, let's add some parentheses in here and in here. Perfect. Another way you could have written this is, let's duplicate this line, Ctrl D. Let's comment it. New vector3 with x and y multiplied by the grid scale. And we can remove everything in here. Perfect. This is actually shorter. So let's keep this notation. Okay, we should be good. So now let's go back to Unity and try this out. But we first need to set up our grid scale. Don't forget that. So let's use a grid scale of 1 just to check if everything is still working as expected. And it is. So now let's set this to, let's say 3. Okay, hit play. Perfect. What about .5? Yeah, it seems like it's working, but we forgot something. We need to scale down our spheres. It should be using this scale. So let's go back to our script. And after instantiating the sphere, what we can do is actually store it or cache it. Game object sphere instance equals this. Sphere instance dot transform dot local scale equals vector3.1 times grid scale to apply the scale to the sphere. Now let's go back to Unity, hit play, and here we go. We can now play with the scale. So let's set it to 1.5, let's say, boom. And it does adjust automatically the position of the spheres and their scale. And this will come in handy again when making the puzzle. So in the next one, let's start using quads and apply a texture to start playing around with the tiling and offsets. See you in the next one. Welcome back, guys. In this lesson, we are going to switch from using spheres to using quads so that we can play with the texture a little bit. But first off, we need a texture, of course. Come on. So yeah, let's add a texture. So I'm just going to create a new folder for materials. Okay. Right click again, create a folder for the textures. Here we go. And I'm going to grab a texture and come back to you. Here we go. Here is my texture. It's a place in Morocco. It's actually called the Blue City. So yeah, come and visit. All right. So the first thing we are going to do with this texture is create a material so that we can actually use it. So let's right click inside of the materials folder, create a new material and call it, let's say puzzle piece. Like so. Perfect. We are then going to apply that texture. So let's click on this little circle right here and select the texture that you've added. You can use this one. I'm going to try and add it as a resource that you can download along with this lesson, or you can use any texture that you want. So I'm going to use it. Perfect. I'm going to set the smoothness to 0. Awesome. And let's actually use an unlit material. So universal render pipeline, unlit. Here we go. And right away, you can see that we can play with the tiling of the image and the offset. Perfect. So let's set it back to its original values. But to make sure that this is working correctly, please make sure that the wrap mode here is set to repeat. If it was set to clump, now let's reselect the material. Okay, just so that I can show you. The tiling, if you increase it, will give weird values. It's actually using the last pixels on the edge of the image. So yeah, make sure that your clump mode is set to repeat. The wrap mode, sorry, is set to repeat. Like so. Here we go. All right. So now we can apply this material to our prefab. So let's select our prefab and call it quad. Let's open it because I don't want to use a sphere, but I want to use a quad instead. Here we go. We should be good right here. So let's assign the material. Where is it? Here it is. Perfect. Let's now go back to our main scene. It does use the quad. Let's hit play. And our texture is now displaying correctly in our grid. That is so cool. Let's increase the values here, maybe 5 and 0.75, something like that. Yeah, cool. So now, do you remember what I've said right here? So we use 0.33 right here to 0.66 to 1 for a 3 by 3. For a 5 by 5, it should be 0.2, 0.4, 0.6, 0.8, and finally 1, something like that. So let's actually experiment a little bit in here. So I'm going to select this piece. I'm actually going to use a 3 by 3 grid size or maybe a 2 by 2. And let's set a scale of 1. Here we go. So that's it's easier to play with. So for the bottom left, the tiling should be 0.5, 0.5. Okay, so it's the same for all of these. But the offset should be 0, 0. Cool, this one is working. Now let's try and duplicate this material just so that we can apply it to this quad and play a little bit with the offset. So let's use 0.5 and it's actually perfect. So now you notice that if we move the pieces, they actually form the bottom half of the image. And if we create 2 other materials, it's actually going to work similarly. So yeah, now what we need to do is change the tiling and offset of each material assigned to each quad. Okay? So here is what we're going to do. Inside of the grid generator, now that we've spawned it, what we can do is access the material of the sphere instance and change its properties. So let's first calculate the tiling and offset. So vector2 tiling equals new vector2. The x value should be 1 over, let's actually use a f for a float, 1f divided by the grid size. Okay, same thing for the y-axis. So 1f divided by grid size. This is because we have an equal amount of lines and columns. If it was not the case, we should use different values, but let's keep it simple for now. Vector2 offset equals new vector2. Now the offset will be different. It should be x divided by the grid size in here. And of course, don't forget to turn this or to cast it into a float. And for the second axis, so for the y-axis, we are going to write float y divided by the grid size. Like so. Perfect. So if x equals 0, this is going to be equals to 0. And this is exactly what we want. So from 0 to 0.33. So this should be 0 at first for the offset, of course. This should be .33 and .66. So let's now go back here and assign these values to our material. So sphere instance dot get component of type render dot material dot main texture offset equals offset, of course, and same thing for the tiling. So this is main texture scale, if I remember well. Let's just double check the scale of the main texture. Yeah, it should be it. So yeah, we are good to go now. Should we give this a shot? Let's hit play. Yeah, it seems like it's correct. Awesome. So now the image has been configured correctly. Let's actually bump up the grid size to 10. And if I zoom out, sorry. Yep. Okay, that is good. So nice. This is the first step to creating our puzzle game. Awesome. So now you know how to split a texture or an image into multiple parts. In the next one, we are going to learn how we can use the input class to move these pieces. And you're also going to learn how to use Unity Remote to control the game via your smartphone. That's going to be nice. See you in the next one. Welcome back, guys. How are you? Okay, so just before moving the pieces, what I propose to you is to rearrange our elements a little bit so that it does make sense. So, our grid generator here is actually the puzzle generator. So let's rename it. We are going to open it and select its name, hit Ctrl R twice to rename all of the instances of the script, and write puzzle generator. Here we go. So now it should also rename here inside of Unity. So cool. Then this is now the puzzle generator. Awesome. Let's right click and create an empty parent that we are going to call puzzle. So the puzzle will have a puzzle generator as a child. The sphere prefab here is actually the puzzle piece prefab. So let's rename it. Let's hit Ctrl R twice. Puzzle piece prefab. Here we go. We can also rename the sphere instance here. So this is the puzzle piece instance. Here we go. And finally, you can either scale it in here and change the material right here. But regarding object-oriented programming, it's not optimal. What we will do instead is calculate the tiling and offset right here. That's okay. But we are going to create a puzzle piece script that will be responsible for changing the scale of the puzzle piece and the material scale and offset, actually. That's going to be better. So let's go back to Unity. Let's create a new script. Let's call it puzzle piece. Here we go. Now we are going to open our prefab again. Let's rename it puzzle piece. Okay. Let's open it. And what we're going to do here is duplicate this element, and it's automatically going to be turned into a child of itself. We can remove the quad from here and the mesh renderer because I want the renderer to be an object in itself. So puzzle piece renderer, here we go. And we can now attach our puzzle piece script. Open it. Let's add a reference to the renderer. So elements. Serialize field, private, render. Here we go. Let's add a way to configure our piece. So public void configure. We should pass in the scale. So float scale. vector2 tiling, and vector2 offset. Nice. Render.material.main texture scale equals tiling. Render.material.main texture offset equals offset. And transform.local scale equals vector3.1 times the scale. Awesome. So now we have a way to configure our puzzle piece inside of its own script. So now let's go back to the puzzle generator. What we're going to do is instead turn this into a puzzle piece. Let's copy this, paste it here. Okay, so now we are instantiating a puzzle piece. We can remove this line. Okay. By the way, what size? Oh, the grid scale, of course. And in here, what we can do is write puzzle piece instance.configure by passing in the grid scale, tiling, and offset. Here we go. So now this is way cleaner. We configure our puzzle piece in its own script. So we are, of course, going to try this out. Let's pass in the renderer first. Here we go. Let's go back in here, specify the puzzle piece. By the way, you can either lock the inspector or right-click and select properties to have a floating window of your puzzle generator. Let's open the prefabs, puzzle piece. Here we go. Close it, play, and yeah, same behavior. That is so cool. Okay, so we now have a puzzle generator, a puzzle piece that is responsible of itself, and we're good to go. So in the next one, let's add control. See you there. Welcome back, guys. In this lesson, we are finally going to try and control our puzzle pieces. Okay, so the first thing we want to do is to create an input manager. So let's create it right away. C# script, input manager. Here we go. Let's create that game object. So create an empty input manager like so. Let's reset its transform. And I want to rearrange my hierarchy a little bit. So what I'm going to do is grab some utility classes that I created and that you can find in my Code Ninja course, if I remember well. So yeah, make sure to have a look at it. And you can also have a look at Mobile Mastery. So go check out tafsil.com. Okay, I've imported some utilities. So now there is a tools organize hierarchy menu right here that I've used just now. And this does allow me to set up my hierarchy. So puzzle inside of gameplay, directional light, and main camera inside of the environment. Here we go. That is way better, right? So, okay, so I can now attach my input manager to the input manager game object and open it. Perfect. So here is what we're going to do. Inside of the update method, we are going to manage our input. So manage input. Private void, manage input. Then inside of this method, we are going to check if there is specifically one finger pressed on the screen. So if input.touchCount equals 1. Inside of here, we are going to manage single input. As simple as it gets. So manage single input, because later on we will allow the player to rotate the pieces, so it will need 2 fingers, and also zoom in and out with the camera. So again, 2 fingers. So we will have a manage double input method. Okay, so inside of here, we are simply going to grab the position in screen space of our input. So vector2 touch position, let's say, equals input.touches at index 0, because we know that there is one input at least, dot position. Cool. But we now need the world position. Why? Because we are going to check if the position pressed by the player is close to a piece or not. So we will ideally grab the closest piece from the input position. Okay. So this is a way of doing things, and of course there are multiple ones. We could have used raycasts, but I don't want to use physics for something as simple as a jigsaw puzzle game. But this is another possibility, of course. Okay, so we've got the position. So vector3 world touch pause equals camera. main.screen to world point touch pause, like so. And this does give us the world touch position. Then what do we want to do with this? Well, we first need to check which phase the touch is at, because there is the begin phase when you press the screen, there is the drag phase when you drag your finger around, and so on. So we are interested by these two and another one, the ended phase, whenever the finger is released, actually. So switch. Let's actually store the phase somewhere. Yeah, touch phase. Touch phase equals input dot touches at index 0 dot phase, like so. So depending on the touch phase, if this is the begin phase, so when we have pressed our finger on the screen, we need to check if we've detected a piece or not. So let's just break for the moment. Default break. Here you go. And of course, I don't want to add the logic right here because this is the input manager command. It should not be the one responsible for moving the pieces around. So what we're going to do is add a puzzle controller that will do just that. So here is what we're going to do. First off, let's check if we detect a piece or not by asking the puzzle controller. If we detect a piece, we can start moving it. Perfect. If not, it means that we want to move the camera, and we are going to add camera movement later on, of course. So if not, try or maybe move the camera actually. Okay. So let's add our puzzle controller into the game now. So I'm going to go back to Unity and create a new C# script, puzzle controller. Here we go. So to add our puzzle controller, we can actually create a new game object, let's say. So puzzle controller as a child of the puzzle game object, and attach this to the puzzle controller, of course. And finally, we can open it. Yeah, let's do that actually. Inside of this script, what we're going to do is catch whenever we've pressed the screen with one finger. So public bool and why bool, because it should return true if we've detected a piece, so that the input manager knows that we want to move a piece and not move the camera. If it does return false, it does mean that no piece has been detected, thus we want to move the camera. Okay? So let's call this finger down callback, something like this, or maybe single touch began callback. And of course, we need the world position to check if there is a piece nearby. So inside of the input manager now, we can add a reference to our puzzle controller. So elements, serialized field, private puzzle controller, puzzle controller. Here we go. And inside of the began logic, if puzzle controller dot single touch began callback with the world touch pause, it means that a piece has been detected. So we can return after doing our logic. So we can move it and return. Otherwise, or break actually, you can also break. Otherwise, we will need to move the camera. Okay. So now let's go back to the puzzle controller. Okay, we've got our world position. We need to return true or false if we've detected a piece. But who says detected? It says a detection radius, or a distance, at least a minimum distance that we need to check if we've detected something or not. So in our case, the minimum detection distance will be the size of a puzzle piece. So let's say we click right here at the bottom right. It means that the minimum size should be the distance from the center to here. So it's square root of 2 multiplied by the grid scale. Okay. So yeah, we can actually hard code this to 1.4 or 1.5 times the grid scale. Okay. So it means that we will need the grid scale. So here is what we're going to do. Let's create a header for the variables. So settings, let's say. private float detection radius. And our puzzle generator or a puzzle script will need to pass in the grid scale that we've got right here or right here to the puzzle controller at start. So let's add a reference to our puzzle controller right here, serialized field, private puzzle controller, puzzle controller. I just want to keep things simple for now. At start, puzzle controller.configure with the grid scale, like so. And let's now create a configure method. So public void configure float grid scale. Okay. So we can now set up our detection radius equals grid scale times 1.5, let's say. Cool. So we now have a detection radius. Let's detect if we've found a piece around the world position. So here's what we're going to do in the next one. First off, grab the puzzle pieces. And this will be given to us by the puzzle generator. Okay. Then we'll need to grab the closest one to the world position. And of course, later on, we will not grab the closest one, but the top closest one. Because we can imagine that the puzzle pieces will be stacked on top of one another at some point in the game. Of course, this is a situation that can happen. And finally, once we've grabbed the closest one or the top one, we can start moving the piece. 3 simple steps that we are going to try and cover in the next one. You there? Welcome back, guys. In this lesson, hopefully we are going to start moving the pieces because, come on. Oh, 3 lessons now that we haven't moved them. So yeah, let's go on. So we first need to grab the puzzle pieces from the puzzle generator. So of course, we will need some way to do that. So let's add the puzzle generator to the configure method. So puzzle generator, okay? Just so that we can reference him or it somewhere around here, maybe elements. Private puzzle generator, okay, like so. So we can store it. This dot puzzle generator equals puzzle generator. Perfect. Then store the grid scale. And of course, we need to implement this with this just to pass in the puzzle generator. So now our puzzle controller is aware of this guy. What we can do is add a method inside of the puzzle generator to return all of the puzzle pieces. So in here, we instantiate them. We can add them to a list, let's say, and have a method that returns that list. Or we can grab them from the children because we spawn them as children of the transform. But let's store them. That's actually cleaner. So under the settings, we're going to write private list of puzzle piece. Puzzle pieces equals new list of puzzle piece. Just before generating the grid, we want to write puzzle pieces.clear just to have a clean list. And every time we create a puzzle piece, puzzle pieces.add puzzle piece instance. Cool. So we now have a list of all of our puzzle pieces. Let's create a public puzzle piece array method that returns the puzzle pieces. So get puzzle pieces. Return puzzle pieces.toArray. Cool. You could also return a list, but an array will do the job. Now we can go back to our script right here, grab the puzzle pieces. So puzzle piece array, let's call it puzzle pieces equals puzzle generator.get puzzle pieces. Cool. So we now have a reference to all of our puzzle pieces. Now let's grab the closest puzzle piece to the world position. I'm going to rush a little bit into this because we've already covered this in another course. So let's write puzzle piece closest piece equals get closest piece. We will pass in the puzzle pieces and the world position because the detection radius is a class variable, so we will be able to access it. So let's create that method, private puzzle piece get closest piece with an array of puzzle pieces. So up like so, and vector3 world position. Okay, perfect. So float min distance equals 5,000. Okay, a really huge value. Int closest index equals -1. And let's now loop through all of the pieces. So from 0 to puzzle pieces.length, what we can do is grab the distance from the puzzle piece to the world position. Float distance equals vector3.distance from puzzle pieces at index I dot transform dot position to the world position that we've clicked. Perfect. And if that distance is less than the minimum distance, first off, we can check if it's within the detection radius. So if distance is greater than detection radius, let's just continue and prevent iterating over this piece. But if it's less than the minimum distance, then the closest index should be equal to I, and the minimum distance should be this distance actually. Perfect. So we now loop through all of these. Let's now check if the closest index is less than 0. It means that we haven't found any puzzle piece close to the clicked position. Let's just return null. Otherwise, we are going to return puzzle pieces at index closest index. Perfect. So now we've got the closest piece. Just to make sure that we've got it, let's just destroy the closest piece .game object and return true maybe. So let's check if closest piece equals null. Let's return false. Otherwise, we will return true after doing all of our logic. Got it? Here we go. Let's now go back to Unity. Let's check if we need to reference something. Yeah, the puzzle controller in here and the puzzle controller inside of here. Cool. Let's hit play. Let's try and delete some pieces. And it doesn't work. Why? Well, there are actually two reasons to that. The first one is that our world position is not correctly set up. If we come here and try and debug.log the world position, it's going to return 0, 0, maybe with -10 along the z-axis for the camera. So let's just hit play. And if I click, of course, 0, 0, -10. This is because our main camera right now is set to perspective, and we need to set it to orthographic. So let's jump up the size to 7 maybe. Let's hit play. Yeah, that's actually decent. We can now click, and we got the correct world position, of course. Cool. So now we need to deal with the z-axis. It needs to be set to 0 because all of our pieces here have a z of 0. So just so that we are on the same plane, we are going to set our world position to 0. So here's what we're going to do. Inside of the input manager right here, we can write world touchpose.z equals 0. Perfect. Now let's go back to Unity, and hopefully it should be fixed. So let's hit play. Let's click. Boom. Nice. Okay. So the first piece has been deleted now, but when I try and destroy another one, it's not working properly. This is because the puzzle piece still belongs to the list right here when it has been deleted. Of course, in game it will not happen because we are not going to remove or delete puzzle pieces. Come on. But yeah, to better test that, what we're going to do is actually move it up. So closest piece dot transform dot position plus equals vector3 dot up. Yep, something like that actually. So let's go back to Unity. Hit play. And yep, now when I click a piece, it goes up. So let's start with the top row so that I can actually test this out. Okay, here we go. Nice. Seems like it's working. Okay, so we can now detect pieces on the grid. What we are going to do next is try and move the pieces. So the move logic will be inside of the puzzle piece. Each piece will be responsible for moving itself. See you in the next one. Welcome back, guys. In this lesson, hopefully we are finally going to move the puzzle pieces. All right, so where did we left it? This is the input manager. So let's just open it. Okay, so we've got single touch began. Cool. Let's hold control and click this to be taken to the method. All right. So we did move the piece up right here and not destroy it. Perfect. So it means that we've detected the piece. The first thing we want to do here is to let the closest piece here, so that puzzle piece, know that it's going to move. So let's tell it to start moving. So closest piece dot start moving. Like so. Why? Because we want to store that position, the first position, the one at the beginning of the movement, so that whenever the input manager detects a movement of the finger, so when the phase is drag, let me just add that. So case touch phase dot moved, like so, not dragged. Let's break. But right here, we are going to call the puzzle controller, and if we've got a piece that is moving, then we are going to move it with this new position. And of course, we will need to calculate the difference between the position at this instant and the position whenever we started the movement. This is why we need to store that initial position. So let's open our puzzle piece and add a public void start moving method. Perfect. So inside of this method right now, we are simply going to store its initial position. So let's add a new header, movement, let's say, something like that, yeah. Private vector3 initial, or maybe start position, something like that. Let's call it start move pause. Yeah, cool. So in here we need to store it, start move pause equals transform dot position. Perfect. Of course, we will need another method, public void move, with a move delta, so a variation of movement. Let's call it move delta. And finally, public void stop moving, like so. So why do we need a start moving and stop moving? So we can imagine having or wanting to play a sound or moving the piece up or scaling it up whenever we start moving it, maybe animate it. I don't know. We could do so many things whenever we start the movement. And same thing whenever we stop the movement. If we've risen it up right here, we will definitely want to move it down again after we've stopped moving it. Got it? So this is a way to actually have a lot more flexibility on the animations and the effects you want to apply. So once this is done, let's tackle the moved phase right here. So here is what we are going to do. If we were controlling a piece, we need to tell the puzzle controller that we are currently moving the finger. Otherwise, the camera should be responsible or should detect that movement. So what I propose to you is to add an enum, maybe right here at the top. Yep, somewhere around here. So enum state, and we've got two states. So puzzle piece and camera. Are we controlling a puzzle piece or a camera? Private state state. Okay. At start, let's also add a non-state actually, just an idle state. So at start state equals state.none. Perfect. But right here, if we've detected a piece, state equals state.puzzlePiece. Okay. That way we can check which state we are in right here. So if state equals state.puzzlePiece, then we are going to call the puzzle controller dot, I don't know, single touch drag, maybe single touch drag with the current world touch pause. Got it? And of course, after that, we are going to have the else if state equals camera. So boom, then we want to move the camera out. So either call the camera controller or send an event. Again, it's going to be, you're going to be free to decide whatever you want to do. So single touch drag. Let's copy this method name, open the puzzle controller script and add that public void single touch drag, vector3, world position, of course. And in here, the first thing we want to do is calculate the difference between the clicked position, so this one, and the new world position. So it means that we need a reference to that clicked position. So let's add it somewhere around here. Piece movement, let's say. We will definitely need a move speed. So private float, move speed. Okay. And we also store that position. So private vector3, clicked position. Maybe move start position again. Yeah, something like that. Let's call it clicked position for now. So we want to store it somewhere around here, equals world position. Perfect. And inside of here, we can now calculate the difference between these two positions. So vector3, move vector or move delta equals world position minus clicked position. Perfect. So now that we've got this move vector, we can pass it into the puzzle piece. And I don't know why I've added the move speed, because we're actually using screen space or screen positions. So yeah, no need to add the move speed. We want the piece to be at the exact position of the finger. So move vector, okay, we've got it. And we need the closest piece, so the piece that we were moving. So instead of calling this one closest piece, what I'm going to do is rename it current piece. I'm also going to remove the call or the instantiation from here because I want to make it a class variable. So private puzzle piece, current piece. Okay, perfect. That way I store it here and I'm able to use it inside of this method. So in here, I can again double check. So if current piece is different than null, then current piece dot move with the move vector. Okay, and I can rename this move delta actually, just to keep a consistent naming style actually. But yeah, that's the same thing. All right, so now that I've got this move delta, let's use it. We can write vector3 target position equals the start move position, so the initial position at the start of the movement, plus the move delta. And this way of coding allows us to prevent moving the piece continuously. Instead, it's going to move to that position and stop, because this is a fixed value, okay? So once we've got the target position, we can simply write transform.position equals target position. Really simple. Or we can apply some interpolation for a smooth movement. So what we can write is something like transform.position equals vector3.lerp, linear interpolation between the transform.position, the target position, and for the timing, I'm going to use time.delta time times 60 if we play the game at 60 frames per second. But yeah, we are using time.delta time to make it consistent across different devices. Times, let's say, .3f. I like to use this value, but yeah, feel free to experiment with these values here, of course. I can now comment this and give it a shot. So no need to implement the stop moving method for now. We are going to do so later on when we'll want to check for validation. Like whenever the piece has been released, of course, we need to check if it's at its right position in the puzzle or if it's close to a neighbor, okay? To be able to link it to the neighbor and create a group of 2 or multiple pieces. Okay, so now we can just try the movement. All right, I don't think I've got things to implement or reference here, so we can safely hit play. Okay, I'm going to select this piece, try and move it. Yeah, awesome. That's actually really good. Nice. So if you notice well, whenever I stop moving the finger or the mouse in this case, the piece stops moving. But if I just move it a little bit, it's going to move to the target position. Yeah, exactly. Okay, so it means that we can grab it from the bottom left, and move it here. That's gonna be good. But yeah, the thing is that the interpolation is not happening whenever the finger is stationary. So here is what we are gonna do. We are going to add one more logic layer. Inside of the input manager, I'm gonna add case touchface.stationary. And if the finger is stationary while being in the puzzle piece state, so puzzle piece, we are still going to call the puzzle controller.singleTouch, not began, but drag method, world touch pause. That way, even if we don't move our finger, the piece is still going to try and move towards the target position. So let's try and move it. Yeah, that's better. I love it. Awesome. So we can now move the pieces around. That is so cool. I'm going to bring the camera back a little bit, or maybe change the size of the puzzle. So maybe the grid size can be 5. Okay, let's hit play. Yeah, that's better. Okay, here we go. Perfect. So you now know how to control puzzle pieces, squares actually. But don't worry, we're getting there. Awesome. So now if I move the pieces around a little bit, you can notice that, for instance, this one goes behind this piece, above this one, behind these, above this one. Like the sorting order is weird. This is because all of our pieces are within the same plane at z equals 0. Okay? So to fix that, I've come up with a technique that we are going to use because we are in 3D. We can't use the sorting order of a sprite, for instance. Okay? It would have been nice, but in our case, we need to deal with the Z position. And this is exactly what we're going to do. We could have used a shader, but I think that this one is a little bit simpler to implement. So yeah, in the next one, let's do just that. Welcome back, guys. In this lesson, we are going to manage the Z order, so the sorting order of the pieces. Because again, right now they are all within the same Z plane. And we want this one, the one that we've picked, to be above all of the other ones. Okay? So here is the method that I came up with. First off, let me open the puzzle generator script, the one that's responsible for spawning the pieces. And inside of here, here's what we are going to write. So we spawn it at a certain spawn position, but we are going to add some variation to the spawn position.z. So spawn position.z plus equals, or maybe minus equals, a certain value. So let's use a random value, or maybe create a variable for that. So let's create a header here. So header z sorting, serialized field, private float, piece z offset. Okay, we can use this piece z offset right here, times the index. So we need an index from x and y. We can easily calculate this index. Let me just bring back the drawing in here. Okay, so I'm just going to select this. Can I clean it a little bit? Okay, let's do this. This is the text. Where is this drawing? Okay, right here. Perfect. I actually need the grid, so I'm just going to disable this one and re-enable the grid. Okay, so this one, B, please. Perfect. This should be index 0, the bottom left one. Why am I not writing? Okay, so this is index 1, this is 2, 3, 4, 5, 6, 7, and 8. Okay, so these are the indices that we should get. So this is 1, by the way, it's not visible. So to get the index, we are going to grab y. Oh, I can't write here. Okay, perfect. Thank you. So I'm just going to write a simple text. Y plus the grid size times x. So for this one, let me just reselect this one. Okay, perfect. Maybe another color. Boom. So for this one, it should be y is 0, grid size is 3, and x is 0. So it does give us 0. Perfect. Then for this one, x equals 0, y equals 1. So this is going to be 1. For this one, x equals 0 and y equals 2. So it does give us 2. And for this one, y is 0. So that's 0 plus 3 times 1. 3 times 1 equals 3. So this does give us 3. Awesome. Same thing for this one. 1 plus 3 times 1, 4. 2 plus 3, 5, and so on. Okay? So we are going this way. Okay, so let's implement this inside of our script now. So let's create a method for that. Private maybe, int grid index from position. I don't know, something like that. From pos, int x and int y. And this should just return y plus the grid size times x. As simple as it gets. Okay, so now we have a way to grab the index of the cell or of the puzzle piece from its x and y position. So we can use it right here. Grid index from pos, let's pass in x and y, and this should be good. So now every piece should be brought back towards the camera. Okay. Oh, the piece z offset, of course, is 0 for now. So let's set it to 1 just for testing purposes. And yep, it does work. Awesome. All right. So some of the pieces are not visible because they are behind the camera, if I'm right. Yep. So what I'm going to do here is change that. So let's reselect the puzzle generator and set it to a really small value, 0.001, let's say. Let's now hit play. Press F to focus the pieces. And we can notice that they are slightly offset one from the other. Okay, so if I'm right, this one should be the top one, so it should be above all of the other pieces. Okay, that is perfect. This one should be the bottom one, so behind all of the other ones. Yep, okay. So this one should be above the previous ones. Yep, but below or behind the other ones. Perfect. So now each piece has a Z position. What we're going to do now, whenever we select a piece, is bring it before all of the other pieces and push all of the other pieces back. That way we make sure that we are always grabbing the top piece. So some of you can ask here, why don't we keep all of the pieces at 0 and just move the selected pieces at, I don't know, maybe z equals -1, just for it to be before all of the other ones? Well, whenever you're going to drop it again, let's say right here, it's going to be brought back to 0. You're going to have to manage that case. What does happen when you release the piece? Should you keep it to z equals -1? Or should you bring it back to z equals 0? So if you drop it above another piece, it can disappear, go behind it, because it will have the same z value. It's going to be weird. Another way you could have done it is to initialize all of the pieces to z equals 0, so on the same plane. And whenever you select a piece, so let's say this one, you bring it forward. So let's say something like that. But if you select another one, you will need to keep track of that one too. So you will need to bring it 2 times forward. And at a certain point, you will go behind the camera and your piece will not be visible. So that's why I've decided to use this logic. It does ensure that all of the pieces keep a consistent Z value without going too much backwards and too much forwards. They'll always move inside of this zone. Okay? Perfect. So in the next lesson, we are going to go on and make sure that we implement this logic correctly. See you there.